Hey guys, all right, so we're going to start on proof number 4 now. And so, again, first things first, let's draw in what we know is given. So I know that AB is congruent to BD, so AB is congruent to BD. Good, now I also know that AC is congruent to CF, so 2 marks now. AC is congruent to CF. All right, and then finally I know that BC is congruent to DE, so BC is congruent to DE. All right, good. So I've got a couple pieces of information here. And well, okay, let's go ahead and make a roadmap. So I need to know that ABC is congruent to BDE. So let's write that down here. So we want to know that triangle ABC is congruent to triangle, let's look up top. What did it say? It said triangle BDE. Okay, so let's look up here at what our evidence might be for that. So it says that we want to prove that ABC is congruent to BDE. So now this looks very similar to the one that we did the other day, but we've got some different evidence now. And so what am I going to be able to prove here? Well, so right now I don't know that I can do anything with these 2 tick marks. So these I don't know if they're useful to me because I can't transfer those on over onto BDE, so I don't want to focus on those, but I do know that I've got a side and a side. And so anytime I have 2 sides, I should automatically be thinking side angle side. So to do side angle side, then I would need to somehow prove these pieces, that those 2 angles right there were congruent. And so this one's a little bit more complex, guys. There's a couple more steps in here. So the last time we did this, we were able to prove that 2 angles like that were congruent. Well, we're getting ahead of ourselves. Let's go ahead and come down here. And we think that we're going to go side angle side. Okay, so let's draw in what we need for side angle side. So we need that, and we need that. We need these 2 angles. So let's name those 2 angles. That's ABC. So we think that we need angle ABC to be congruent to BDE. Okay, to BDE. Now, how are we going to do that? Well, last time what we did is we saw that those 2 things were corresponding angles. Okay, so what we did is we noticed that we had a parallel line and a parallel line that were cut by a transversal, and that these 2 angles then, this angle and this angle, were in corresponding locations on our 2 intersections. So let's say now, we think that might be a good path. So let's go ahead down here and let's say that we're going to prove that by saying corresponding angles. And that's one of our theorems, right? It should be on the cheat sheet. Let's take all of this and make it smaller. We'll shrink it on down. And then I'll write angles nice and big here. And then I can shrink it too. Okay, so I've got angles, and I'll go and I'll stick it right there. Okay, perfect. So I've got my last 2 steps, but I still don't think that I have enough information to prove that those are corresponding angles. And the big issue here is that there's nothing right now that says that BC is parallel to DF. And so I need something. If I could say that, if it had given me BC is parallel to DF, then I'd be golden. We'd be done already. But it didn't say that. So that's what I need right now. So let's say what I need this. I need to say that BC is parallel to DF. Let's write that down here. Let's say that BC is parallel, remember our notation, to DF. Oh man, things are getting sloppy. Okay, so how could I possibly prove that? Well, if we think back to the stuff that we learned last class, remember we had that thing called a mid-segment, and a mid-segment was when we drew a segment between the midpoints of 2 sides. And if we think about what a midpoint is, let's look at this side, so AD. Well, the midpoint of AD would cut AD into 2 equal parts. So because I see that I've got two equal parts in AB and DB, then that means that B must be a midpoint. Okay, so I've got one midpoint. And then if we look at AF, well, the midpoint of AF would cut AF into two equal parts. So because AC and CF are equal parts, that means that C must be a midpoint. Okay, this is all good stuff because if B is a midpoint and C is a midpoint, that means that BC must be a mid-segment. All right, and if BC is a mid-segment, then I automatically know that the mid-segment, because of the mid-segment theorem, that the mid-segment BC is parallel to the third side, which is DF. So what I'm going to say down here is I'm going to write in mid-segment theorem. And that's my piece of proof. Now, if we think back to the mid-segment theorem, that would also mean, let's make all this stuff look nice and match. That would also mean that BC is exactly half the length of DF, which in this case is not necessarily it's not necessarily really helpful to us, but that might be good in future proofs. So we've got enough right now. Okay, so I've got side angle side, or I've got my triangles are congruent because of side angle side. This was the only piece of information I needed for side angle side. We proved that because of corresponding angles, and we needed this piece of parallel information to be able to prove corresponding angles, and the mid-segment theorem went ahead and gave us that piece of parallel line information that we needed. So that's our proof for number 4.